Basically, in this video, I'm going to show you how to set up the machine and get it ready for welding. The machine actually comes with quite a comprehensive instruction book. If you go on the Artec's website, you can also download basic TIG welding instructions. Before we start with the machine, I want to talk a little bit about safety. The light emitted from any form of arc welding, MIG welding, TIG welding or stick welding is bad for you. It'll burn your eyes, it'll burn your skin. To sort of burn your eyes, use a welding mask. In the old days, or a bit of ordinary plate glass and a handheld shield. This is a screen I've had for quite a few years. It's a speed glass screen. It's been quite good. It has one problem. On low amps, able about 20 amps on AC, welding aluminium, it sometimes goes bright. The sensors can't cope with a low amperage setting. I bought one from Artec, that XL screen. XL because it's got an extra large viewing area. It's a lot bigger viewing area than my speed glass one. It also has 4 sensors. I have used it and it doesn't go bright at low amp settings. There's plenty of room inside it. I wear glasses and there's plenty of room to get me head in with my glasses on. It's all fully adjustable for shade sensitivity. One feature it has got is a little button there. You press the button and that allows the screen to remain light, very light green, so you can grind with it. The temptation is you've got your hat on, you're welding, you need to grind something, you just lift it up and grind and chance it. Or if you try and grind with the screen down, the bastard lens goes dark. This one doesn't, so it's just one little button, so you can put your finger up inside, flick the button and grind away. Quite a nice mask, it is a good fit. It's no heavier than my speed glass. When I bought that, they were state of the art. That was a lot of money. These aren't a lot of money. I think they're 50 quid. Real good value for money. The other thing is gloves. Not just because sparks and things are hot, and you might touch something hot. The ultraviolet rays will actually burn your hand. I mean, you've seen my hands, they're a bit, they can stand a bit of heat. But I do wear gloves for welding. These are TIG welding gloves. Once again, they come from the same people. I've got a couple of pair. These are nice and light. What I generally do, I'm left-handed, so I have a TIG glove on my left hand for the wire, and I put a big welding glove on my right hand to hold the torch. Normally, it's just the way I do it. So you need gloves. You need a face mask. You need to keep your forearms covered up because they'll burn. That bit there burns badly. The V there. I was once tacking up, stick welding outside. I had a mask on and everything, welding away, and I got a real bad burn there. I had to go to the hospital. It was like sunburn, all the skin was coming off. So it will burn you. Eye protection, gloves, make sure any skin's covered up. Cotton's ideal, don't wear nylon. One other thing, don't wear these. Do not wear them when you're welding or burning. You get a spark on a night rail and a rubber glove, it can go into your bloodstream and it doesn't do you any good. It's really bad for you. So you don't wear rubber gloves when you're welding. The other danger, of course, with an electric welder is electrocution. Don't use it outside in the piss and rain. You know, it's not rocket science. Be careful what you're doing. Make sure the machine's grounded, earthed properly. I've wired this one up through a 16 amp supply, so I can use the full 200 amps. You can run it on a smaller supply, but you can't use the full potential of the welder. We'll start at the back of the machine and only do things arse first. Obviously our power cable. There's a point there, it's a ground point. If you get problems with interference, you sometimes get the AC interferes with your radio, put an earth feed from there to your bench. Obviously a metal bench, not a wooden one. That's your gas in from your bottom, your regulator. There's an output there. It's an output 240 volt for a water cooler. If you run a water cooled torch, that's the main on off switch. But the first thing we'll do, we'll connect the gas hose to the back of the machine. The hose comes ready assembled with crimped on ends, organs right hand thread, flammable gases like propane and acetylene are left hand thread. Just nip it on, you don't need to be ridiculous with it. Right, TIG welding, you probably know what TIG welding is, or you wouldn't be watching this video. It stands for TIG, stands for tungsten inert gas. Use a tungsten electrode with an inert gas to shield it. The inert gas you use is argon, high purity argon. It's a bottle of HP argon there, high purity argon. I think a half side bottle. Ideally this should be on a trolley with a welder. I'll give you a bit of advice. I learnt this the hard way. Tie the bottle to something. You put your next door regulator on your flow meter and you kick the bastard over and it smashes the regulator. I've done it. To secure it to something. Not going anywhere. It's simple. That is well worth doing, because I can assure you if you don't do it, you'll be welding away, you'll bump the bottle and it'll fall over. Right, so I've got my bottle of gas. Gently crack the valve. Just to blow any debris out of the end of the valve. Got your argon regulator. Regulator comes with a welder. Once again, it's right hand thread. Screw it on. Nip it up. You haven't got to go ridiculous, but it's going to be tight. Right, your regulator pressure from 2500 psi in the bottle down to 5 or 10 psi for welding. What I use as well, I use a flow meter. If I want the cuts, it's well worth having. It tells you exactly how much gas is going through the welder in litres per minute. You want about 8 litres a minute. Without that, it's a bit of a calculated guess as to how much gas you're using and you end up wasting gas. Right, so I've got my regulator on, put a gas hose on, nip that up. Simple as that. Right, so that's our gas supply connected. There's two what they call DIN connectors on the front. There's a positive one and a negative one. TIG welding, you use positive earth. Stick welding, you use negative earth. So your earth you're using your positive terminal, just pushes in, half a turn and it locks in. That's the earth that goes onto your job. Or you'll put it on your bench, obviously not a wooden bench, I've got a metal welding bench. So that goes to earth. That's simple enough. Right, we've got our torch connections. Once again, negative, electrode, negative. So it's positive earth, negative torch. That's the power cable, the thick one that goes up your torch. And you've got a gas feed, argon feed, and you've got a control feed, control plug for the on-off switch on the torch. Put the gas feed on, a little brass nut going onto the top of the pipe. Simply pushes on and the nut screws on, holds it firmly in place. It's only low pressure, but we don't want to leak on, wasting gas. Right, so that screws on tight like that. Then you would fit your torch connector. It goes in one way, plugs in, and it's got a nut to secure it. I'm not going to use this at the minute. I'm going to use a foot pedal. I like to use a foot pedal. That's the foot pedal. That goes into the same connector. Pushes in. So we've got a gas supply, we've got an earth, we've got our power out to our torch, we've got our control for our foot pedal to turn the welder on and off and reduce and increase the amperage. Right, Tig torch. I'll do a little bit about the torch, how you put an electrode into it, tungsten rather. Right, basically the welder comes with two different types of tungsten, red tungsten and a white tungsten. Red tungstens of our steel, white tungstens of our aluminium. You can get a grey one which does either. You can get pure tungsten. There's several variations on tungstens, but basically red one for steel, white one for aluminium, grey one does both. It comes with 3 different sizes of tungsten for different amperages. The handbook tells you what size tungsten to use for what amperage. We're going to be welding steel, so we need a red tungsten. So what happens is you get your torch, your tungsten, you've got a coloured body made of copper, you've got a copper coloured holder. What you do, you screw the holder into the torch, you drop the collet in the back, you put the collet on the cap on the back of that. This is what they call a long cap, so you can use the full length of the tungsten. As the tungsten wears down, you use a shorter one, or you can cut the tungsten short and put a little stubby cap on. Tungsten goes in there. Tungsten goes in there. That tightens up on the collet and that stops it from moving. Then you've got a ceramic, it screws on. That directs your gas. You normally want the tungsten sticking out 1.5 to 2 times its diameter. The tungsten needs to be sharpened to a point on a grinder, not a needle point but a nice little point for steel. You don't need a grinding point on the white ones for aluminium. You end up with a ball when you weld it. Saying that, I do grind a slight point on. We'll get to that when we'll start welding. Right, so a quick recap. Red tungsten steel, white tungsten alloy. Different sizes of tungstens. That's a medium sized one. You get smaller ones for less amperage, bigger ones for higher amperage. Like I say, the book has got a chart in the book telling you what diameter tungsten to use for whatever amperage you're going to be using. When you put the tungsten in, put the painted end in so you can tell what sort of tungsten it is when you take it out and put it away. So 1.5 times to 2 times the diameter of the tungsten sticking out. Right, as you can see there's a shitload of buttons and knobs on the front of here. I'll go through each one in turn and tell you what it does. The book actually tells you what to do. If you really want to know about setting the welder up, have a look on YouTube channel or Welding Tips and Tricks. A guy called Julie runs that welding channel. You'll learn a lot by going there. I'm not a welder, I'm a motor mechanic that can weld. Anyway, I'll go through the switches, show you what they do. I'll tell you what they do. We'll do the switches first. Switch on there, it's got MMA Tig. MMA stands for manual metal arc stick welding, and Tig, tungsten and gas, which is what it's going to be doing most of its life. I will, however, be doing some stick welding with it. Inverters are great for stick welding. Right, next switch down, this one says AC DC. That's the money switch, the expensive one, because AC DC welders are twice as much as a straight DC welder. Right, AC, alternating current for welding aluminium. DC, direct current for welding steel. Steel, titanium, Inconel, stainless. You can also weld copper and bronze on DC. So AC, alternating current, aluminium. DC, direct current, steel. So switch there, 2T, 4T switch. That's got to do with the control on the torch, different types of welding. It does for pulse welding. We'll be doing that later. We'll do a bit of pulse welding. Right, we'll do the knobs, or at least the knobs that concern us at the minute. First knob here, that's your power knob. That sets how many amps the welder is putting out. I'll turn it on. It's right down there, 5 amps. Turn it up and up and up. 100 amps, all the way up to 200 amps. So all you set that to is determine how much power you get out of the end of there. See, I use a foot pedal, so you basically leave it on full setting and control your power by the foot pedal. Normally what you would do, you would look at the job and see 100 amps will weld that, so you set it at 100 amps, you can't go above that. Next one along is your pulse current. That's for pulse welding. We'll talk about that when we come to do pulse welding. Arc force, that's got to do with stick welding. Post flow, that's important. You're welding along quite happily and you stop welding. What happens is on your post flow, that keeps the gas coming out to allow the tungsten to cool and to allow the weld to remain protected by argon shielding gas until it solidifies. It's gone from 0 to 25 seconds, you set it about halfway, 12 to 13 seconds is ideal. That's important. It's not wasting gas, it is important. Right, we've got AC balance. This is again for welding aluminium. AC. What AC balance does, it controls how much cleaning effect the alternating current has on the weld. If you set it down to 30%, it'll have the electrons are going friggin' ballistic and they're cleaning the metal, etching the metal clean. You set it up to 70 and it gives you loads of penetration but not as much cleaning. Basically you want it set at about 40. This one here, AC frequency, that's how fast it goes, how the alternating current works, positive, negative, positive, negative. On old-fashioned transformer welders you are stuck at 60 Hz. With this one it goes from 50 all the way up to 250. What this does, it has the effect of tightening up the arc. If you set the arc like a flame, if you have it down at 50 you've got a wide bushy flame. If you turn it all the way up, the flame tightens to a pencil point. You can hear it as it's welding, as you wind it up, it starts to screech higher and higher and higher. Normally aluminium, but 120 is the sweet spot for welding aluminium. That one there, that's to do with pulse. That's to do with pulse. These two, you've got an upslope and a downslope. Therefore, when you're using the trigger control on the torch, what they do, your upslope, when you start the welder up, it increases the amperage gradually up to whatever amps you've preset that at. When you let off the trigger, it slowly fetches it down to whatever, from whatever amps it was welding at, down to 0 in a controlled manner. You don't need to sharpen tungstens for bollocks.